7D. Determine the linear factors of a polynomial function of degree 3 and degree 4 using algebraic methods. Factor each completely. State the method used for each and provide or show details. On number 19, we have x squared minus 16x plus 64. Let's factor this one. We're going to identify A, B, and C. A is 1, there's 1x squared. B is positive 16, and C is positive 64. Draw our x. A times C is 64, and B is 16. We're going to find two numbers that multiply to give you 64, and they add to give you 16. So your factors of 64, we could try each number. We would try 1, 2, 3, 4, 5, 6, 7, and then we know 8 times A is 64, so we could stop there. Because the smaller number would no longer be the smaller number. So 64 divided by 1 is 64, so 64 times 1 is 64. If we do 64 divided by 2, we get 32. 64 divided by 3 is a decimal, so we could cross that one out. It's not a factor. 64 divided by 4 is 16. 64 divided by 5 is a fraction, a decimal. 64 divided by 6 is also a decimal, and so is 64 divided by 7. From there, you're going to write the sums of those numbers. We have 65, 34, 20, and 16. The factor pair that works here is 8 and 8 because we have our factors that multiply to give you 64, and then we add them together, it gives you 16. So our factors would be x plus 8 and x plus 8, so that would be x plus 8 squared. Let's look at number 21. 12v squared plus 76v minus 160. Well, all three of these numbers are even, so we could take out a 2, so we could factor 2. So we'd have 6v squared plus half of 76 is 38v, and then minus 80. Now notice we also have another 2 that we could take out because these are all three even numbers. So we have 3v squared plus 19v minus 40. Okay, so from there, there's nothing else it looks like we can factor out. No more greatest common factor, which would be 4. You'll have to show both of these steps. You could just directly factor out the 4. So from here, we're going to identify A, B, and C. A would be 3, B is 19, and C is negative 40. Draw our x. A times C is negative 120, and our B is 19. We're going to find two numbers that multiply to give you negative 20, and they add to give you 19. So from here we can list out some factor pairs. Do that on the side. And then we will find the sum of 19. This is a negative number, so we're going to have a positive number and a negative number here. And the bigger number is going to be positive because our answer needs to be 19. So we'll try 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And if you can find the factors right away, you don't have to write out every single factor. This is just for those that are not sure where to start. So negative 120 divided by negative 1 is 120. 120 divided by 2 is 60. 120 divided by 3 is 40. 120 divided by 4 is 30. 120 divided by 5 is 24. 120 divided by 6 is 20. 120 divided by 7 is a decimal. And you can also put these in the calculator if you're not sure what those quotients are. So 120 divided by 8, we get 15. 120 divided by 9, that's a decimal, so we could cross that one out. 120 divided by 10 is 12, and then 120 divided by 11 would also be a decimal. So we'll find the differences for each of these and see which one gives you 19. So if you look at your differences here, it would be 24 and negative 5. So we could write that right here, 24 and negative 5. So from here we're going to write our factors. We have v, well, we have a 4 on the outside, and then v plus 24 times v minus 5. We're going to divide by a, which is 3, for each of the factors. Reduce the fractions. You can do that in the calculator. So we get 4 parentheses v plus 8. And then this one doesn't reduce, so we just slide the denominator to the front. 3v minus 5. And these would be your factors. Let's look at number 26. We have m squared minus 1. Recall from Algebra 1 your difference of squares formula. A squared minus b squared equals a minus b times a plus b, where these two factors are conjugates of each other. So if we find a squared, that's just m squared. To get a, we're going to take the square root of each of these. So a would equal m. B squared would equal 1. To find b, take the square root, exponentiate both sides by 1/2. b equals 1. So your factors would be, if you put these in the formula, is m minus 1 times m plus 1. And these would be your factors. You'll use this same formula for all difference of squares on this page, so all 3 of these. Now, number 29, we have a sum of cubes, and we also have a difference of cubes. Let's go over those 2 formulas. So for the difference of 2 cubes, we have a cubed minus b cubed equals parentheses a minus b times a squared plus a times b plus b squared. These 2 signs will always be the same, and then these 2 signs will always be opposite. The last operation is always going to be positive. So if we did this for the same thing for the sum of squares, or sum of cubes, we would just need to change some of these signs. So we're going to have a plus sign here, a plus sign here, and then a minus sign. And that's for sum of cubes. So let's use that formula. So on number 29, we have x cubed plus 64. So a cubed would be x cubed, and b cubed would equal 64. To get rid of the cubes, we're going to take the cube root of each side. The cube root of x cubed is just x. The cube root of 64 is 4 because 4 times 4 times 4 is 64. And then we'll just plug those into the formula right here. So we have x plus 4 parentheses x squared minus 4 times x plus b squared, so that'd be 16. And these would be your factors. So what you need to show on this on these kind of problems is to state the formula and then find your a and your b. Plug them into the formula to get your factors.